Welcome to the deep dive. We often talk about pushing connectivity forward, faster, sharper visuals. But today we're kind of doing the opposite. We're going to dig into a piece of tech designed to lovingly drag the modern digital world back to the chunky, warm world of analog video.
Yeah, our focus is incredibly niche today and maybe a bit pricey for what it appears to do. It's the WolfPack HDMI to S-Video and Composite Converter, part number HDTV CM388, and it costs right around $300. Now, that price tag, it immediately tells you this isn't for just anyone plugging in an old VCR. This is specialized. So our mission for you, listening in, is to understand why this specific, pretty expensive technical bridge even exists. Its whole job is taking a pure digital signal, HDMI or DVI, and actively translating it back, converting it into standard definition analog like S-Video and Composite.
Right. And what's really interesting here is how this technology is a direct answer to, well, obsolescence, basically. It's not just a passive adapter, connecting pins. This is an active conversion. It takes a clear digital input that's key, an HDMI or DVI source that doesn't have content protection, and it turns that signal into a legacy standard. So NTSC or PL systems, plus you get your LR stereo audio out. It's the kind of hardware that lets people keep using maybe expensive, dedicated, older equipment.
Okay, let's unpack that core function. Starting with the outputs, we're talking about bringing back connections that haven't been standard on TVs or stuff for maybe a decade, right? It converts that digital HDMI stream into the two main analog standards. You've got S-Video, which for analog was always the slightly better quality option.
Definitely better than composite.
And then the classic composite, that single yellow RCA jack everyone knows.
And crucially, it handles both global standards. You actually get a little switch on the unit itself. So you can flip between NTSC, that's mostly North America, Japan, and PLL, which you see in Europe and lots of other places. That flexibility, it really points towards its use in, say, professional setups or archives where you might have gear from different parts of the world all needing to work together.
Okay, that makes sense. But that $300 price tag, it only really clicks when you understand the why. Tell us about the specific problems this converter solves, the real-world applications mentioned in the source material.
Well, the applications are almost all about professional integration or archiving, where new sources meet old recorders. Think about maybe specialized video conferencing units, the ones that don't encrypt their output. If you need to record what that unit is showing onto an older dedicated AV recording system, maybe a specific type of DVR that only takes analog, this converter is basically your only option. It's the link.
That absolutely makes sense. It's the sort of technical glue holding things together in maybe a corporate or industrial setting.
Exactly. Or, maybe on a slightly more fun note, it solves problems for certain entertainment setups too. Like imagine you have a modern PC or some media player putting out high-quality karaoke video and audio, but it's unprotected. And the only screen you have for your, party room or basement bar is an old CRT TV with just S-Video or composite inputs. This device lets you keep using that old TV.
I love that example. It's also probably vital for connecting, say, a PC or a laptop with an unencrypted HDMI output straight to a standard definition TV. That happens a lot in things like digital signage, maybe industrial monitoring, where the displays themselves often last way longer than the computers feeding them. Right, so we know what it converts. Now, here's the big technical challenge, isn't it? HDMI can carry, huge resolutions, 1080p, even higher now, and we're taking that massive stream of data and trying to squeeze it down into the much narrower pipe of standard definition analog. How does this converter handle those high-res inputs?
That process. It's called down conversion, and yeah, that's where the real work inside the box happens. It's actually pretty versatile on the input side. It accepts standard HDTV resolution starting at 480p, going all the way up to 1080p at 60 hertz. Although it's interesting, the documentation notes it specifically excludes 1080p at 24 hertz.
Oh, the movie frame rate.
Exactly. So that tells you it's probably more optimized for standard TV broadcast signals, PC outputs, or maybe higher frame rate video, not necessarily Blu-ray movie playback directly. And on the PC side, it takes signals from VGA at 60 hertz right up to UXGA at 60 hertz, which is 1600 by 1200 pixels. The clever part is that the device automatically detects that incoming high-res digital stream. Then it scales it, down converts it to fit the much lower specs of either PARL or NTSC analog. It's quite a feat of, signal processing.
That really is impressive processing power, all dedicated to basically stepping backward in time technologically. But here's where things get really interesting and potentially quite frustrating for a regular user. The source materials, they're very clear, emphatic even. This device has a critical limitation. It is explicitly NET HDCP compatible.
Yes. This is probably the single most important thing to understand about this hardware. HDCP, that's high bandwidth digital content protection. It's that encryption handshake, It's required by pretty much all commercial media companies to protect copyrighted stuff as it goes from a source like your Blu-ray player, your streaming box, your display. And because this converter doesn't have that digital key, that handshake capability, well, it just won't work with almost any modern consumer entertainment device. Plug in a standard cable box, a satellite receiver, a modern game console, an Apple TV, anything that enforces HDCP. The screen will likely just be blank. So this device is strictly limited to sources that output a clear, unencrypted signal. And that immediately tells you this is a tool for specific industrial uses, or maybe archiving, justifying both its niche market and that higher price.
Wow. So if you went out and bought this $300 converter thinking, great, I can archive my favorite shows from my cable DVR,
Yeah.
you'd be completely shut down by the encryption. It really highlights that the design goal here is utility, it's legacy support, it's not about getting around content protection.
Precisely. And even when you are using an approved, unprotected source, the documentation points out some specific configuration steps you often need to take to get the best results. For instance, it recommends you first set the HDMI source device's resolution down to 480p. It's kind of the lowest common denominator, right? Set that before starting the conversion. And there's another potential snag. If the source input isn't displaying full screen, maybe it's letterboxed, black bars top and bottom, or pillbox, black bars on the sides. If that's the case, the final analog output image might end up incorrectly sized or maybe positioned weirdly on your old TV screen.
Oh, that sounds like exactly the kind of frustrating problem that would make someone just give up and think the converter is broken. Is there a specific fix for that? A technical solution?
Yes, there is. And it gets into the nitty-gritty of video signals. The source material says to fix that sizing or positioning issue, first make sure your input source is set to output a full screen image before you even power on the converter. But here's the really specific kind of technical tip for the listener. You then need to go into the source device's menu, the menu of your PC or whatever is sending the HDMI signal, and find the HDMI color space setting. You need to set it to YCBCR.
YCBCR. Okay, that sounds like alphabet soup to anyone not deep into video engineering. Can we break that down? Why on earth would changing a color setting fix a sizing problem?
It seems counterintuitive, doesn't it? But YCBCR is a color space that's specifically designed for video. It separates the image data into luminance, the Y, basically brightness, and two components CB and CR, which handle the color difference information. Now, the old analog standards, NTSC and PR, they were also fundamentally built around separating brightness from color information. That's how they work. So by manually telling your digital source device to use YCBCR, you're essentially telling it to format its color information in a way that very closely mirrors how the final analog signal needs to be structured. This kind of signaling alignment helps ensure that when the converter does its downscaling and conversion, it uses the correct geometry and the right color sampling that the analog system expects. And that resolves those weird letterboxing or positioning errors. It's less about resolution, more about the underlying signal architecture matching up.
That is a fantastic explanation. It really shows how sometimes the biggest hurdle between old and new tech isn't just speed or pixels, but something as fundamental as how the devices... Well, think about color. Okay, one quick but important point on physical limits before we move on. This is strictly a one-way street, right? Digital to analog only.
That's correct. You absolutely cannot feed an S-Video or composite signal into this box and get an HDMI signal out. It is purely a down converter. No going the other way.
Good to clarify. All right, let's look at what else justifies the cost beyond just the basic conversion, the advanced features. And a big one seems to be the HDMI Pass-Through, sometimes called a bypass feature.
Yes, including that pass-through is really important for its professional use case. Because the unit has an HDMI loop out, you don't have to sacrifice your high-def view, just make an analog copy. You can watch the original, sharp, high-definition picture on a modern monitor at the same time as the signal is being down-converted for, say, an analog recorder or maybe a standard def monitor somewhere else. Perfect for things like live archiving or monitoring setups. The audio handling is also pretty comprehensive. The unit actually gives you 4 simultaneous audio outputs, which covers most bases. You get 1 SPIF digital coaxial output. You get 2 standard stereo all-R analog outputs, your red and white RCA jacks. And the HDMI audio from the input is also passed straight through the HDMI loop out, assuming, of course, your source actually has audio embedded in the HDMI.
Okay, wait. The audio setup sounds a bit complex there. We know it converts the digital audio from the HDMI input into the analog stereo outputs. That makes sense. But what if someone uses the other digital input? What if they feed a coaxial SPDIF signal into the converter's input? Does that digital signal also get converted to the analog stereo outputs?
Ah, that's a really crucial distinction highlighted in the source material. And the answer is no, it doesn't. If you feed a coaxial SPDIF signal into the designated input, the unit basically just acts as a pass-through for that specific signal. It only pushes that incoming SPDIF stream directly out to the SPDIF coaxial output. It does not decode or convert that SPDIF audio into the analog stereo channels. For that specific input, it's just a pass-through, not a converter.
Got it. Okay, that definitely clears up potential confusion during setup. Let's talk compatibility beyond just standard HDMI. What about DVI? The connector often found on older PCs. How does this WolfPack unit handle that?
It handles DVI quite well, actually, as long as you stick to the digital side of DVI. The source is listed as compliant with HDMI 1.2, HECP 1.1, even though it doesn't use HCP and DVI 1.0. This means it supports single-link DVI-D. You connect it using just a standard DVI to HDMI cable or a little adapter. No problem there. The documentation also mentions it can specifically accept a PC's XGA DVI signal on its input. That's 1024 by 768. And here's the technical nuance we need to be clear about for the listener. You know how some DVI connectors are DVI-I, meaning they carry both a digital DVI-D signal and an older analog VGA signal on different pins.
Right, the ones with the extra pins around the flat blade.
Exactly. This converter, being focused on digital to analog video conversion, will only process the digital DVI-D part of that signal. It ignores the analog pins entirely.
So if I plugged in a DVI-I cable coming from my computer, the converter would actively just disregard the analog part of that signal.
Precisely. It only cares about the digital stream. So this leads to a specific warning. If you were thinking you could plug a DVI to VGA adapter onto the output of this converter to get an analog VGA signal, well, that won't work because the converter isn't passing through that analog component from a DVI-I source, nor is it creating a VGA signal itself. If you specifically needed analog VGA out, you'd need a totally separate active DVI-D to VGA converter somewhere else in your chain. This box sticks strictly to processing the digital source into composite or S-Video.
That distinction perfectly captures the kind of headache you can run into with all these mixed signal standards. It makes sense.
And just a final note for maybe those of you listening in institutional purchasing roles.
Yeah.
The documentation specifically mentions the product is TAA compliant.
Ah, yes, TAA.
For the listener, that means it adheres to the U.S. Trade Agreements Act. That's often a requirement for government buys, university purchases, large institutions.
Yeah.
Further cementing its position as more of a professional tool than a consumer gadget.
Good point. It's another piece of the puzzle explaining the niche and price. Okay, so let's quickly wrap up what we've dug into here. This WolfPack converter costing around $300, TAA compliant. It's a highly specialized piece of kit. It's essentially the necessary technical bridge, a mechanism needed to keep older, legacy analog recording systems or displays working when you need to feed them from modern, high-resolution, but crucially, unprotected digital sources.
Yeah, and if you step back and look at the bigger picture, the very fact that hardware like this needs to exist specialized, professional grade, and explicitly non-HDCP compatible really highlights this ongoing tension in tech, doesn't it? You've got content owners pushing hard for strict encryption, HDCP everywhere, which inevitably locks out older or non-compliant devices. And then you have users, professionals, archivists who desperately need interoperability. They need the freedom to use the perfectly good equipment they already own or to archive material. This converter basically exists in that gap, that space left open because of the content protection wall.
That's a great way to put it. It's like technology finding the little cracks in the system to allow things to keep working. And maybe as a final thought for you, the listener, to chew on today, let's go back to that really specific setup detail we talked about. Remember having to set the HDMI source's color space to YCBCR just to fix geometric sizing issues on the analog output? Makes you wonder, doesn't it? How many other digital to analog conversion problems, maybe not just in video, but in audio or data transfer, how many hurdles exist purely because of these fundamental mismatches in signaling protocols, or how color is represented rather than just a lack of raw speed or processing power? It's a fascinating hidden layer of complexity, something to maybe think about the next time you find yourself trying to connect a shiny new device to a trusty old screen.